Uh, Ferrocement has been a very interesting proposition to me from the very beginning. That I got introduced to it by Milind Kulkarni. He's not here today. And later, ever since I got introduced to ferrocement. By the way, I am from a different discipline, if you say. I belong to a discipline of common sense, if you say. So, since I'm a fundamental mechanical engineer by degree, the moment I heard about ferrocement and saw its wonderful properties, I think the same day when they introduced, I became a life member of the society. And then I've been using it for a number of applications. The future of ferrocement is here, especially when the code will come. So I usually say there is a urgent versus important matrix which is taught in organizations. It's urgent, not important, important, not urgent, and so on and so forth. Similarly, RCC is okay. There are four possibilities how ferrocement and RCC can go together. So if you draw a matrix, you draw RCC y-axis and you put ferrocement on the x-axis, you'll have four quadrants. Okay, you'll say not okay, okay. So there are some places where RCC is also not okay, ferrocement is also not okay. So in another quadrant, you'll find RCC is okay, but ferrocement is not okay. In the third one, ferrocement is okay, but RCC is not okay. And the last quadrant is all are okay. All right. So generally, this is the famous I am okay, you are. So this can be a relationship. So you can find and depending on the application. Depending on the application, you'll find four quadrants, and I see the possibility of all these four quadrants playing up in course of time. I would like to quote two technical examples for this. Since he's a mechanical engineer, you must have heard of 3D printed buildings. I've been in touch with Larsen and Toubro, which has built a post office made by 3D printing. There have been videos over the internet. Some German companies have also done it. What I'd like to tell you is you can build ground floor, you can build first floor. I told L&T people that can you build for me a 3-storied building? They said, we are sorry, nobody does it because it lacks columnar stability and there are a lot of problems. So ferrocement is the answer. If you see, so what I was saying is, where is ferrocement actually applicable? So the thing is, if you take space items, why is aluminum used instead of steel for aircrafts? Because the materials which are used for aerospace industry have got high specific elasticity. That means elasticity per unit mass. Matlab, it is like not this fat or if you say slenderness ratio, the L by D ratio is one of the measures. So if you see specific elasticity of ferrocement is very, very, very large compared to RCC. And therefore, wherever there is a specific elasticity or a specific weight reduction required, RCC will fail very badly and only ferrocement will succeed. So this is some input for everybody. So if you want to make a structure very sleek, then ferrocement is the answer. Okay. And this is a generic rule. So there's a certain ratio for which ferrocement has got the best applicability. So this is the technical part of the story. Now over to the beautification. So when we think of beautification, we have to think of architects anyway. What I would like to say is there are several applications of ferrocement which is not being explored. So one is in the area of mineral processing. There are a lot of domes which are made in steel which are rusting. And this need to be converted to concrete structures. There's a big demand for this. There's a big explosion in the medical industry and in the pharma industry where cooling towers need to be built. They are built out of RCC. We need to make it out of ferrocement. So there's a big market. There's a big demand for IoT-based towers. There's a big demand for IoT-based Internet of Things structures. There's a big need for structures to be embedded with electronics. Okay, where RCC is not doing a good job. Now, your many buildings are complaining that we don't get mobile range. All right, which is a complaint we all have. The answer to all of this lies in ferrocement. So there's a big opportunity out there where a lot of exploratory stuff needs to be done. Also, production of ferrocement and reduction of labor costs, which address some of these things. If we have precast ferrocement structures coming up for artistic shapes, it is possible by application of mathematics. I can see that there are mathematics softwares which are available in which wild structures which can customize, which can meet the needs of your imagination can be done by this.